Prove it's a trapezoid first. Prove it's a trapezoid. So if you got to look back at your notes, look back at your notes. But a trapezoid only has one property. And we need to prove that property exists here. What is the one property we discussed yesterday? Not isosceles, a trapezoid. One property of a trapezoid we discussed yesterday. Start us off right, 17. One property of a trapezoid.
One pair of parallel sides.
Okay, so I need to show probably, and you can go by the looks here, right? We're probably going to show AB parallel to DC. We have been using what formula all unit long to show two sides are parallel? What formula? 4? Not, Griff's not here. 22? Slope formula. So here we go. I'll give you a second. I'm about a minute in your group right now. Let's find the slope of AB for me. And then find the slope of DC for me. And we'll reconvene here in a second. All right, so go ahead, discuss with your groups. What's the slope of AB? What's the slope of DC? And I'll ask you in a second. 14. What's your slope of AB? Do we have a 14? Yes, no? Okay. How about 6? There we go. 6, slope of AB? 1 half. You guys got 3/6, which is 1 half. What about the slope of DC? 5/10, or also 1 half. So everyone's good. All right, I got some bad news, though. That's not going to be good enough. Showing me those two sides are parallel. Here's why it's not good enough. We're trying to prove this a what? Trapezoid. That could still be a parallelogram, couldn't it? Yeah? Everyone agrees? This is something that a parallelogram would have. So how do I disprove it's a parallelogram now and just solely say it's a trapezoid? What else must I do here? Mood, you got a suggestion? And that's exactly what you need to do to prove a trapezoid is. Yes, prove one pair of opposite sides parallel. And if you take a look at above, and one pair of opposite sides not parallel. So I am going to have to find the slope of the other two sides, AD and BC. So go ahead in your group, another 30 seconds there, AD and BC. Okay, AD, what do we got for the slope of AD? 20, slope of AD. Good, make sure everyone's negative. Don't forget it's negative. And BC, Jonathan? -1 half, yep. Does that scare anybody that it's -1 half? No, as long as it's not +1 half, we're okay. Those aren't negative reciprocals or anything, so don't worry. We've been doing this through every coordinate proof. If you use a formula, step right after, what did you just learn? What did you just learn? It's not a trapezoid. That's not what we learned. What did we learn about some of the sides up there? Oh, not going to fall for it again. 19. What did we learn about some of the sides up here? AB and DC parallel. Yep, let's stop right there. How do you know?
Because they have the same slope.
Good, because slopes are equal. And what did we just learn about the other set of sides? Oh, 6.
They're not parallel to each other, so AD is not parallel to BC.
There you go. AD not parallel to B. And hey, you can use the parallel symbol with the little slash. Feel free. Because slopes are not equal. Yeah, yeah. All right, so guess what? We got a trapezoid on our hands now. That's good enough. One pair of opposite sides parallel, the other's not. They're the only thing it could be is a trapezoid. We've eliminated every other possibility of quadrilaterals. So ABCD is a trapezoid. Because, what do you think here? I need a good reason. I need a good reason here. That in your reason, it's going to tell me it's definitely a trapezoid, and you are going to eliminate all the other possibilities in your reason. Talk to me in your own words. Why is it a trapezoid? 21, why is it a trapezoid?
Because one pair of opposite sides are parallel.
Could be a parallelogram. Got to add more to that.
And the other pair is not
Perfect.
parallel.
Perfect. Everyone see why you had to add in and the other is not? All right, because if Ella stopped right where she was, that could have been a parallelogram. So because one pair of opposite sides parallel and the other is not. Good. Jamie, yeah.
Oh yeah. Couldn't you just put like an only before that?
You could put the word only. Yeah, that's the other way of seeing it, is only one pair of opposite sides are parallel. Perfect. Perfect. All good? Mahmood, what's your deal?
Would you have to say that it's like you have to also prove that's not a isosceles trapezoid?
No? I'm not. Just prove it a trapezoid. We're good. All good? Because an isosceles trapezoid is a trapezoid. So, all right. Now, speaking of isosceles trapezoid, how do I prove an isosceles trapezoid? Like, this is so disappointing. So disappointing. Like, maybe a couple reactions from this group up here, but nothing else. Do you even know what I'm talking about?
Yes,
That the Promethean guy just came up, and you have a legit chance. Legit. All right. I'll say that. Classic. Went to the revote, and you picked the other one. Oh, man. So many bitter people right now. I told you to vote for it. This wasn't meant to be, guys. This wasn't meant to be. All right, we're going to prove this an isosceles trapezoid now. We're still going to do it the same way as we did the trapezoid, except we need a couple extra steps after. So I'm going to give you guys about 2 minutes in your group. Prove to me this is a trapezoid right now. And then we'll talk as a group, hey, how do I make an isosceles? So same format as last proof. Prove a pair parallel, another pair not parallel, say it's a trapezoid. A little refresh. AR and NO. Slopes of two horizontal lines. 0. Yep, 0. No rise over run there. All right, so go ahead. You and your group, let's prove it a trapezoid first. Make sure you guys have the same slopes. Oh, man. That was great. All right. Are we all trapezoid good? All right. Now my question is to you guys: how do I make an isosceles now? If you need to look back at the 3 properties I gave you yesterday, because I need to pick one of those properties and show it exists. The one property we could probably rule out is base angles congruent, right? I don't think I'm going to prove the base angles congruent unless they're right angles, and they certainly don't look like it. So I have 2 other options. I can prove, what's one option? Caitlin?
One pair of sides congruent.
I can prove the other pair congruent. The non-parallel sides, the legs, we called them yesterday, congruent, or I could do diagonals congruent. Either way I go, I'm going to have to use what formula? Distance, so why don't we just decide, let's prove the legs congruent. All right, so I have a trapezoid. Now I need to prove the legs congruent to make it isosceles. So in your group right now, go ahead, find the distance of AN and find the distance of RO. All right, I'm not even giving you the distance formula. It should be either known or we can look it up pretty quick in your packet. Okay, what is the distance of AN and RO? And hopefully they come out to be the same. Go ahead. What were the lengths of those legs? 24 lengths of those legs? 5. Yep, everyone should have got the square root of 25. And then that would be 5. Yep, 5 and 5. You guys know my rule. If we use the formula, tell me what you just learned from it, right? I just don't want to go saying it's isosceles trapezoid. Tell me what you just learned from your formula. What did we just learn about AN and RO? What did we learn about those 2 sides? Hey, 2. They are congruent. Why, Matt? Because
they're the same distance.
There you go. Distances are equal. Now we can finally say, let's wrap this up, that Nora is an isosceles trapezoid. Because, now I'm going to turn this over to you. What would be a good reason? Don't tell me one pair of opposite sides congruent, because that could still be a parallelogram, square, rhombus, rectangle. What made this into an isosceles trapezoid? Look at all the work you did. Don't just tell me one pair, because the legs are equal. Need more. Need more. 15, got anything here for me?
It's an isosceles trapezoid because only one pair of sides are parallel and the other pair is congruent but not parallel.
That's a mouthful, but correct. Can I shorten it? Because it's basically, let me take the first half there, Serena. You just called it a trapezoid, right? Because it's a trapezoid with congruent legs. But feel free to write that down, what you just said, because that is correct. All right, last thing I want to do with you. In a let's stick with the trapezoid. There is a special segment inside a trapezoid I want to introduce to you right now. A special segment. And that segment is formed if you connect the midpoints of the legs. All right, if you take the non-parallel sides and connect the midpoints, this special segment is formed. So let's do it with our trapezoid right now. And just so you know, I apologize in advance. There is a couple typos here. It used to be trapezoid ABCD, and we changed it to Nora over the summer, so we got to change this. Can you label midpoint of AN as E and the midpoint of RO as F? My apologies. So can you guys find those 2 midpoints in your group right now? Ooh, somebody should gonna have to tell what's the midpoint formula. Hopefully one of you 3 or 4 know what it is, right? Here you go. Find the midpoint of AN, call it E. Find the midpoint of RO, call it F. I'll get back to you in a second. What's the midpoint for each of them? Come on. Oh boy, make sure you're talking your group. What the heck was that midpoint formula again?
I think it's I think it's I think it looks like this.
Yeah, so it's over to.
It's got to be minus. So
Oh,
it's 4.5 was not.
So it's good.
Oh, unless I
don't think it matters. I think it's I'm gonna do y minus negative 1, or 1 minus negative 3, and then do 6 minus 6.
Is it?
It's A. Oh, no, it's 4. Oh, wait, no, he didn't.
Like,
Make sure your midpoint lands on your trapezoid.
Actually, has to be minus. Because 4.5.
Well, you're dividing it.
How we doing here? Uh-oh. Maybe I should have gave you the midpoint formula, huh?
Oh, it's negative 1. Oh, wait, no, I think
Oh, I didn't find
Yeah, it's
for sure.
Okay, can I get some opinions here because we are running out of short on time here. 22 got the midpoint of AN, which is point E. Yep, -1, 4.5. Go ahead and graph it, please. -1, 4.5. There's the midpoint of AN, and what about the midpoint of RO? 13, midpoint of RO.
5, 4.5.
5, 4.5, looking good. Call that point F. And everyone please connect EF to make form segment EF. And I'm not, there's no surprises here. It's at the bottom of your page. When you connect the midpoints of the non-parallel sides in a trapezoid, it's called the midsegment. Midsegment kind of sounds like midpoint. You connect the midpoints. Midsegment. All right. Before we leave, I do want you to get a couple facts about a midsegment. As a class, can we do this real quick? What is the slope of that midsegment EF? What's the slope? Oh, 0. Okay. Can you guys just discuss quickly in your group, what's the length, and I got to change this, I'm sorry, what's the length of AR, not AB, AR, EF, and NO? So find those 3 lengths for me. AR, it shouldn't be distance formula time, I hope not. And NO?
Oh, yes. I didn't see that.
AR? 2. The midsegment? 6. And the other base, NO? 10. You know how a midsegment's formed. I connect the midpoints of the non-parallel sides. Well, what should I know about the midsegment? That's part C and part D here. Part C, the slope was 0. What didn't we come up with another couple sides that also were 0? Right? What do I know about all 3 sides then if they all have a slope of 0? They're all parallel. So go ahead and go to the next page here with the properties. Properties of a midsegment is parallel to the bases. Is parallel to the bases. Why? Because all 3 slopes are equal, 0. Now here's what I want to finish today. Well, we could probably get to the example too. Tell me something about its length. So I'll start you here. Its length is blank. And look at the work we did on the previous page. One base was 2, the other base was 10, and our midsegment was 6. How can I find the length of a midsegment? Go ahead, Bill. Less than a minute here, talking over. How do I find the length of a midsegment knowing the two bases?
Oh, half of it.
So the shorter base, or the larger base minus the shorter base divided by 2.
Oh, yeah. You can just add the 2 bases, divide by 2. The sum
All right, let's go. Going a little quicker here. 11. Did you guys decide on a theorem? We don't. Talk to me, Paul. I'll just put it. I'll put it in math terms.
It's the sum of the smaller side plus half of the difference.
What?
I didn't really get it.
Okay. It's got two bases, right? A trapezoid's got two bases. In our case, 2 and 10, right? 2 and 10, everyone agree? When you add up those two bases, what do you get? 12. Take half of 12, what do you get? The midsegment. Okay, the midsegment length. The length is half the sum of the bases. Okay, its length is half the sum of the bases. Parallel to the bases and half the sum of the bases. Go ahead, let's go. We're going to work right up to the bell today because we had the Promethean man come up, we had Survivor. So let's work right here. So here's 3. Hey, don't overlook it. The trapezoid is isosceles. You got some properties working, and I drew in the midsegment for you, 2x minus 5. So find x, find y. I'll put my work up here so you can check it when you're done. You have those 3 problems following tonight. 3 problems on the following pages.